So now we're looking at expressions that relates all your acceleration, velocity, time, speed, distance, and displacement, so on and so forth. So we're looking at kinematic formula. So we are considering the case of constant acceleration. There's a case wherein there is zero acceleration. That should be commonsensical to you guys. I'm not doing that. So we're looking at constant acceleration. This too is a repetition. This too you guys have seen. But yeah, the representation might be a bit different. So the four things that we'll use directly and indirectly are actually more than this. We'll keep using this and more than this. We'll have to derive for the cases as well. And my suggestion is you learn to derive it. As in, don't remember the formula for the case, each case, whenever you're doing any problem. Try to derive the situation or try to derive a formula for the situation. Now, velocity after certain time, given you have a constant accelerated motion. So basically it would be something like this. So this is of constant acceleration. So if you happen to look at this scenario and your graphs looks something like this, right? Acceleration is constant, velocity is increasing linearly, and distance and displacement, well, they won't be linear. Then we can use the following formulas. The final velocity is equal to initial velocity plus acceleration into time. All of this you guys know, right? The new one might be this one, distance covered in nth second. I'll discuss what is that. So all of this, four formulas, can be derived using algebraic method, graphical method, and calculus method. So we'll be starting off with algebraic and calculus. Graphical, we'll do it in graphical section. Okay. Now, there's a small note, distance covered in nth second. What does it mean? Let me show it. So we have a object moving in a straight line. Let's consider that. Then we have the object, say, every second, or actually I can vary. This is 0 and 1. This is, say, 2, 3, 4, 5, so on and so forth. As you can see, it's not uniform per se. So this is n second and this is n minus 1 second. So this is 0 and this is 1, 2, 3, and 4 and 5, and so on and so forth. So this is first second. This is seconds movement. This is thirds, fourths is over here. Fourth second movement is this. So basically whatever just happened before that is your nth second movement. So if I want to understand what is happening at 10th second, so it is post 9th and when the 10th second ends, right? This is 9th second month. Let's consider this as 9 second. And this is somewhere 0 0.01, 9.0102, so on and so forth, till 10th second, right? If I divide it into 60 microseconds, so we have the counting happening and we are measuring everything, all the displacement that's happening between 9th and 10th second, right? When we complete the 10th second, whatever distance has been completed, that's your nth second movement. That's important for us to understand because while derivation, when we are deriving it or when we are applying it, we need to know. So these are all the formulas. We'll derive this. This is just an introduction video.